Now, typically in the results for a one-way ANOVA, which is what we have described with our example of the cities, we're going to see output that looks like this. We are measuring, again, the between variance, which is going to be between the cities, the differences, the averages between the cities and the sample, and then the within, and this is going to be the variance that is within the city. So, for example, within the wages within London, or the wages within Paris, the wages within Munich. And I'm not going to walk through going the calculation of this by hand. There's some videos that you can watch, and you can do that in Excel if you'd like. But we are actually looking at the average or the mean within, for example, a city, and we'll be looking at the sum square errors. It's very similar to the ways that we had been looking at the calculation of variance and standard deviations, and those are techniques that are probably familiar to you now. And the table is actually going to be displaying the sum squares of this error that we can calculate by looking at the difference between these means and whatever it is, either within or between the cities. We'll be looking at degrees of freedom in the actual test statistic. These are basically the amount of variability that we can count on to look for a difference without actually knowing it. So I'll show you what the formulas are in just a moment. It's just important to understand where these values are in the table. You can actually see the mean squared error here, which is related to the sum of square errors. This is the mean squared error, and if you want to calculate that by hand. And then that gives us the test statistic. It's literally these values, this as the denominator divided into this as the numerator, which will be giving us the F statistic, and then it will be associated with a p-value. So everything that we need to know is pretty much in this table, and they're going to be look very similar across software, and we'll be looking at a number of examples. The calculation and the way that we would write that F statistic, the degrees of freedom between and within was going to be equaling that F statistic. So if I were writing it out, like in a sentence, I would write it as F 2, 15. That's going to be the degrees of freedom between and within, and then the actual F value, which is coming from the table, and what its p-value was. In this case, we have a p equals 0.051. So this is the formula for those. The degrees of freedom between are always going to be the number of groups minus 1. The degrees of freedom within are the number of observations minus the number of groups. So in this case, the number of groups we had were 3. We had 3 cities that we were looking at, Paris, Munich, and London, minus 1. That's what gives us the 2. We had 18 total observations in our study. The n was 18, which you can also see here from that total calculated. And we subtract the number of groups that we have, which is 3, and that's how we get the 15. So in this case, we actually are testing whether or not there are wage differences between those cities, and here we would say no. We cannot reject the null hypothesis. There's no statistically significant difference. The p-value is greater than 0.05 between the wages across those cities. So that would be an appropriate finding. Now, before we leave this analysis, I want to point out that there's a number of different ways that these things are discussed in different textbooks and in different literature. Some people refer to these as the sum squares between and the sum squares within. So that's the way that we've sort of described it here, but you'll also see it abbreviated as SSB and SSW. There's also differences sometimes in the way that these are labeled. This is, in this case, called treatments and error. This is the exact same information that we saw before. It is still the sum squares between and sum squares within, but sometimes it's labeled treatments and error. In this case, because we're using an observational method to talk about differences between cities, we didn't really have a treatment. But that's where this thinking comes from a scientific perspective. If we did have a treatment like a therapy, that would be one reason why we're looking for the difference between treatments, and this is where that kind of language comes from. If it is called treatment, then sometimes it's labeled sum squares treatment, or SSW sometimes, or some squares error. Again, the W would be within, or this could even be labeled SSE, some squared error. It can also be called a factor. So sometimes they refer to these things as factors. In this case, we did have a factor of cities. We had 3 groups in that factor in our sample. And so sometimes you'll see that word factor there. These are all different ways of saying the same thing. Here is the output from SPSS, and you're going to see that SPSS outputs it still a little different. Whatever the variable is, the factor is that we are examining, it will put the name of that factor here. And this is the row that we need to be paying attention to. It has a very similar structure to those that we looked above. And then we have, and this is the between group variance. And then we have the error, which is the within. And its information is going to be here. It also gives us some other information like total. And I'll be showing you in another video how to interpret these and where to put all of the different values. But everything you need is above. There's just some additional information in the SPSS output that we don't necessarily need. The corrected model is the overall F-test. If you have more than one factor, this is going to be an important row to look at, whether or not there's an overall difference. In situations with one-way ANOVA, which is what we have here, there's only one factor, and so these values match. See how the F value in both places are the same. This will be different when we have more than one factor when we look at two-way ANOVA in just a moment. But nevertheless, it's non-significant. There's no significant difference in wages between the samples. We have some additional information here that I'll go to some other videos a little bit later. But this is the way that we would still write that. And again, all this information is the same. So even though it's represented a bit differently, it doesn't mean the interpretation is any different. These are the core areas that we're paying attention to. I'm just highlighting it so that it's on your slide. You can see where that F statistic is being drawn from for a city. In this case, there's no significant difference between the different groups that we looked at in our sample.